Hello, I'm Cloud the Technoid. Welcome to my single focused video web series. Let's dive in. Let's talk about zero trust networking. This is a principle that is driven from the principle of zero trust and zero trust architecture. So zero trust basically it provides a collection of concepts that are designed to minimize uncertainty in enforcing the least privilege principle. So zero trust is based on least privilege. A subject must be provided with the least privilege possible for them to execute whatever they want to do. So in making decision to provision request from subjects, there's need for least privilege to be provided to that subject to access a certain resource. Then the ZTA, this one now it's more like an enterprise cybersecurity plan that focuses on utilizing the zero trust principles in order to protect the enterprise resources. So we're looking at a network infrastructure that is protected physically and virtually using policies, workflow, and decisions. In simpler terms, zero trust implies that we never trust and we always verify. For any request that is coming in, we never trust. So traditionally, we used to have this approach whereby we believed that any attack that comes to our network comes from the external environment. And we used to put as much security here, a firewall that has got IPS, web filtering, antivirus, application control, and so forth. And we believe that as long as anything is allowed or is authenticated to get into our organization, now it's trusted. So there's a concept of implied trust to our environment here, which is the concept that is being addressed by zero trust. And we are saying that modern networks now have micro perimeters in that network. So we have got these micro perimeters. We've got application A, application B. We have got network segment A, network segment B, user group A, user group B, and so forth. And these are micro segments that are existing within the network. And we are saying that if we are to use the perimeter approach, and we want to limit or want to control access between these micro segments, without zero trust, we cannot achieve that. So zero trust comes in and addresses possible threats that are emanating within our environment here. Because remember, organizations no longer exist as islands. We have users that are bringing in their own devices into this environment. We have got guests that are coming in and they want connectivity. So the meantime you authenticate this guest at this perimeter and then they are in, then the activities or the actions that they're doing in this network needs to be monitored, needs to be controlled. There's need for least privilege principle to be implemented. And if that is not implemented, then there is implicit trust on guests, implicit trust on bring your own devices from employees, which now increases the vulnerabilities in our internal network. Before discussing this framework, let's talk about the tenets of zero trust. So let's assume that this is our corporate network and this is the outside world here, remote users, and our internet here. So the first tenet of zero trust is that all data sources and computing services are considered resources. So everything in our environment, be it applications, be it systems, be it storage, they are all considered resources. And these resources, we have got subjects. Subjects can be applications, can be people, or that are trying to access a resource. Hence, there is a relationship between a subject and resource, and this relationship is that the subject wants to access or to consume the resource. So the next tenet is that All communications should be secured regardless of their locations. So the same way we secure this connection via VPN coming to access our resources is the same way we secure this connection that is coming from the internet and coming to access our resource. And it's the same way we secure this connection from a subject that is here, that is trying to come and consume our resources. So we don't have that implied trust that internal resources, they do not require security, they do not require all the enforcement that we are implementing on access to our resources. Third tenet is that access to enterprise resource is per session based basis. As per session, we have to grant this access per session. So we don't have a situation where we say that we have allowed this subject 5 minutes ago and now the subject is trying to access again and we say we are giving it implied access. No, that is not correct. So for every session that we are trying to access the resource, there is need for us to check through the policy enforcement point which interact with the policy engine and the policy administrator to determine whether this subject is still capable of accessing. Else, some sessions can be cancelled or can be denied depending on the posture of this subject. If the posture is not proper or the attributes are not correct or the location is no longer correct, the user who is logging is no longer correct, or it has got an outdated database of antivirus or Windows update and is no longer allowed to access the resource, then access has to be denied. The fourth tenet is that the access to resources has to be through a dynamic policy. It must not be a static policy whereby we say if we have allowed subject X to access resource Y, then we always allow this access. No. So each time that a request is done, then we need to consult the policy, and then the policy has to be dynamic. The attributes that are used to check the capability of this subject to access the resource, they are always dynamic. For example, we check the software versions, the network location, date or time of request, previously observed behavior, the credentials that are trying to access it. So we look at all this information, the analytics, the device behavior, the deviations that could have existed with this subject from the ones that are deemed as proper or as correct performance. If the subject doesn't satisfy any of the dynamic checks that are being done, then access is not granted, it's restricted. The fifth principle indicates that there's need for monitoring of all the resources that are owned or the assets that are owned by the organization. There's need for you to monitor the resources, you need to monitor the subject, you need to monitor the applications, you need to monitor the users, you need to monitor the systems, you need to monitor even the network devices and everything that is in the network. You need to check for patches, you need to check for fixes that needs to be implemented on your enterprise resources, on your servers, on your computers, so that each time you have a correct position of the posture of the subject as well as the posture of the enterprise resources. And with this posture information, it helps to have a correct decision to be made on whether to provide access, whether to terminate any access to these resources, whether to check if the resource or the subject are either compromised or they are not compromised. The sixth tenet is that authentication and authorization is dynamic and has to be strictly enforced before giving access to the resource. So for each access, there's need for authentication and authorization, and there's need for strict enforcement. You can also enforce other authentication mechanisms such as multi-factor authentication to enhance access. Additionally, principles such as re-authentication and reauthorization can also be implemented in this case, so that there's continuous checks even if the session is lasting for more than the stipulated time. Let's say it's lasting for 1 hour. Maybe every 10 minutes there's need for re-authentication, there's need for authorization, just to make sure that the subject still gets the attributes and features that are correct for it to access the resource. And the last one, which is number 7, tenet number 7, is data collection. So we're saying that we need to collect as much data as we can: threat intelligence, logs, SIEM systems. We need to have these SIEM systems. We need to have NOC, the operation center, that also has logs. So we need to collect as much information as possible about our subjects, about our resources, about any changes that are happening in the network. And this information will help us to make the correct decision at the enforcement point here. The police engine and the police administrator will have enough information as they integrate with all these platforms to provide correct information. They can integrate with the AD to see whether the password is expired or is not expired. They can integrate with the SIEM system to see whether there are issues or logs that are being shown by the SIEM system that are wrong activity that is happening at that subject. Maybe they might be malicious or not, threat intelligence. And you can go as far as integrating with sandbox, internet sandboxes, to check whether the performance or the databases versions that are running on a subject are not compromised. Now let's break down the components of the zero trust architecture. Thanks to NIST 800-207, this framework was borrowed from NIST, and it is usual all the vendors, or most of the vendors, they use this framework and these components to come up with the zero trust architecture. So we'll dive into each and of these components just to briefly describe its features, what it does, its characteristics. We start with the subject. The subject here is any resource, application, user, system that is trying to get access to our resource, our enterprise resources. So a subject can be a user, it can be a system to system, it can be another organization that is trying to access our resources. For this subject to have access to the resource, it has to go through the policy enforcement point. You can see that it's coming from the untrusted zone here. This is the untrusted zone. So the trust boundary. So this side is the side of our resources, and this side is the side where the subject resides. And we've got a boundary here which is separated by the policy enforcement point. As indicated, beyond the policy enforcement point, there is this trusted region. This region is the trusted region, and this region is the untrusted region. So the policy enforcement point engages or queries the policy administrator on a decision to make. The policy administrator communicates with the policy engine, which decides on whether a subject has got the right to access an enterprise resource. So the policy enforcement point, it can terminate a connection that is ongoing based on the results or the outcome that is come from the policy administrator. It can also perform monitoring, enabling, as I indicated earlier, terminating sessions. The policy administrator, this is responsible for establishing or shutting down the communication path. So it breaks the communication path. It tells the policy enforcement that please stop this communication that is happening, break it. It's not supposed to happen because of the current state of the subject or the current state of the resource that is being accessed. Whilst the policy engine does the termination, the policy administrator does the termination, the policy engine now is responsible for the ultimate decision whether to grant or to deny access or to revoke existing access, which will lead to the termination of an existing session. Usually it issues a permit or deny, which then will be implemented by the policy administrator at the policy enforcement point. The other components, the content, diagnostic and mitigation system. This one gathers information about the assets of the organization, its current state, and applies any possible patches. The industry compliance, these are the industry requirements. Maybe you are supposed to be compliant with ISO 27001 or any other risk framework that you need to be compliant with. Threat intelligence, there are feeds within the organization and from external of the organization that can be used by the policy engine to make decisions. Activity logs, we have got logs that we keep, the log event managers and etc that keeps logs, and these logs can be used to make decisions by the policy engine. We have got data access policy. This is our policy within the organization which defines which subject has got access to which resource. We have got public key infrastructure. This one is responsible for managing and maintaining the signatures that are used for access. And then identity management, this keeps the details of the subject, the username, the email address, the password, and etc, which the policy engine uses to make a decision on whether to grant access to the resource or not to grant access. And then the same system, this is security information and event management system. It also correlates information about what is happening within the system, logs and so forth, and this security information is used by the policy engine to determine whether to give the subject access or not, because it can have information of the activities that are being done by the subject, and the activities can define whether the subject is performing properly or is doing some malicious activities in the network. Three main deliveries of a zero trust architecture. It's a simpler network infrastructure because it's an intelligent network infrastructure that makes decisions by itself. You don't need to be troubling yourself on, you just define policies and rules, and then the policy enforcement point will just implement these policies dynamically. And then it also a better user experience. So users will just connect. It supports single sign-on. It provides a centralized point where checks are done on whether a user has got access or does not have access to a resource. It also improves the cyber defense. We are saying that the zero trust architecture says that never trust, always verify. So this improves the posture, the cyber security posture of the organization, because you are checking every connection, you are checking every transaction, you are checking every activity that is happening in the network, and you are dynamically provisioning access to resources. The zero trust principles are continuous verification. You always need to continuously verify. As I indicated that even if the session is underway, there's need for re-authentication, there's need for reauthorization. So this enables continuous verification of any session or any transaction that is happening. Limiting the blast radius. There's micro-segmentation. So there's reduction of the segments in the network, which reduces the impact of any, if there is a blast, it has to happen within this segment. Instead of having the perimeter-based trust, we are saying that we create very small segment at application level, at server level, at network level. We have got these small segments, and then we can break trust at any point if need be. So we are having granular segments that reduces this blast radius in case of a net attack. The other principle is automation of context collection and response. So always automate collection of information. We need to be context aware within our environment. We need to see all the attributes of a subject. We need to see all the processes that are happening, the connections, the transactions that are happening within our environment. And we need to know the changes that in states of the attributes of a subject or of a resource that is being accessed, be it in terms of location, security posture, changes in terms of the database versions, whether it's the operating system or the antivirus. And these three are some of the approaches that can be used to zero trust. So the enhanced identity governance, it is based on use of identity to control access. So this one usually it resonates with the perimeter one. When we say that your username and password is correct, you are now given access to the resources, or your certificate that you are using to authenticate is correct, you are given access to the resources. Logical microsegmentation, this one aligns with the limit the blast radius. So on logical microsegmentation, we're saying we're using segments within our network to stop and contain further effects in case something happens in our network. So it's one of the approaches that are used in zero trust. And then network infrastructure and software defined network perimeters. So this one is the logical use of the logical microsegmentation, but through software defined network, which means we are having controllers now that are being queried, that are being communicated to with the police enforcement point to determine whether to give access or to revoke access or to deny access at any given point. So according to NIST, we have got a subject, the untrusted zone, the trusted zone, the resource that we want to access, and the policy enforcement point or policy decision point. We always need to implement dynamic policy and dynamic decisions. We don't have static decisions or static permission. We say we always verify, no implicit trust in when subjects are trying to access the resources. That's zero trust architecture. In zero trust, so we have got a subject that is trying to access a resource. So it goes through a process, and what it goes through is the trust algorithm. So when the subject is trying to access the resource, we have got the police enforcement point and the police decision point, and it goes through this trust algorithm. So the first thing that we have is a subject here, and the subject is sending an access request to a resource, and it is passing through the policy enforcement point, which goes through the trust algorithm. The access request is the actual request that is being requested, but at times we have got information about the subject being added to the request, or the name of the subject, the details, their location can be added on this access request. And those are the attributes of the requests. Followed by the subject database and history. This defines the information about the subject that is trying to access the resource. So we are having the history, whether it has got previous attempts to access the resource, whether it has been marked or flagged that the subject is not in good state, or it has got certain attributes or actions that were not proper within the network. And also it includes the who, like who, anything information about the subject, who is the subject, their history of activities, what were they doing previously in the network. The asset database is also checked by the trust algorithm. This includes whether the device is an on-prem device or company owned, or it's a BYOD device, or it's a guest device. So this will define how the device will be treated based on its asset details. This can also include information about patch, information about OS, information about the softwares that are installed on a device, as well as the integrity of the assets. The resource requirements, this defines what is needed for this resource to be accessed. So we're looking at the minimum requirements for the resource to be accessed. So we're looking at, maybe you need multi-factor authentication, maybe you need encryption on the subject, maybe you need information about the location of the device, so that the device has to be located internally and you don't accept requests from the internet. So This also forms the trust algorithm, whether the request is going to be permitted or the request is going to be denied will be based on the resource policy requirements. And lastly, we'll take a look at the threat intelligence and logs. And this threat intelligence usually is from the internet. We are connecting to Sandbox and other databases that are on the internet. And this threat intelligence also helps to determine whether there are malicious activities that are happening on the subject, which might lead for it to be denied access, or it also provides, we also have logs here, and these logs also provides the behavior, the past behavior of this subject on whether it's supposed to be accessed, given access, or it must not be given access. So again, this is from NIST. Based on the algorithm, we have criteria based versus score based. So on criteria based, we are saying that there are attributes that we are looking at, and if those attributes are met, then we are saying that we are giving access. So we can have attributes such as location, where the subject is located, its updates, whether it's updated or it's not updated, the user details. That's the criteria there, and many other attributes that you can use and measure against. On score based, we give a score level based on the attributes or on the analysis of the activities of the subject, and then based on this score we determine whether we can either allow or deny access. Singular versus contextual. On singular, we are saying that we are just doing a single check, and then if that check is permitted, if is to permit, then we give access. But on contextual, we are looking at the behavior, contextual behavior. We are looking at more information about the subject. All contextual information, we are looking at the 5 W's: who, what, where, how, when. We are looking at the behavior. What was the subject doing for the past maybe 10 hours, or for the past hour, for the past X duration, and then based on that outcome, then we determine whether we give access or we do not give access to a subject. To implement zero trust, we go through the 3 steps. So the first step is to visualize. So you need to identify all your points, you identify all your subjects, your resources. You need to understand your network, your enforcement points. Where are you going to enforce your policies? Where are you going to apply your policies? Which subjects are less trusted? Which subjects are more trusted? And then you visualize and see everything, the architecture and the structure of a network. And then the second step is the mitigation. You need to detect and contain threats as quickly as possible. Stop threats that are ongoing, or stop threats from even happening at all. And then you optimize, you learn, you improve. You learn from the current operations that are happening in your network, and you improve that network. You optimize, you refine, so that you have better trust or better security in your network. Applying this to the NIST framework, so we are talking about the first stage being the assessment. So you do the assessment, you do your system inventory. Which systems do you have? Which applications are existing in your network? User inventory, which users exist in your network, which devices are in your network, which types of devices, which operating system do they use, which antivirus are you using. And then we've got the business processes. Which processes happen in your network? Which subjects and resources communicate with each other? What type of communication are happening? What type of sessions are in your organization? Which sessions are persistent? Which sessions are not persistent? And then from there, we look at the risk assessment and policy development. Based on the information from the assessment, we now come up with the policies. And these policies have to be implemented on the policy enforcement point. and the policy decision point. And then after the policies have been crafted based on risk assessment, we then deploy. After deploying, we operate, and now we are having a zero trust network. So this follows, it's a process. So the meantime we operate, we do the migration feedback, and we start changes, we upgrade, we improve, we start to improve our policy, decision policies, we deploy that, we do again. So it's an iteration, and that's it. It also follows the steps here on the expansion of strategy. We are saying we start with preparing, we categorize, we select, we implement, we assess, we authorize, and we monitor. So this is the same process that we are speaking to on implementing our zero trusts. And after monitoring, we have the information that we can use as improvement. And this improvement, and this information, we are going to use it as input, and we now prepare again the process of implementing zero trust. So it's an iteration again, and we're always improving our network, and that is what continuous improvement in zero trust. This is one of an example of a vendor, Palo Alto, which implements zero trust. So they have got three dimensions, 3 and 4 dimensions, 3x4 dimensions. So we've got zero trust for users, zero trust for applications, and zero trust for infrastructure. Then on the other end, we are looking at identity, device and workload, access, and transaction. So on identity, zero trust for users. So we're saying that we need to validate users with strong authentication. This is where we use multi-factor authentication, 2-factor, 3-factor, 4-factor authentication, tokens, and certificates. We can use certificates to verify. And then zero trust for users against workload and devices who always have to verify user device integrity. Is the user not compromised? Its integrity, is it not compromised? And then on access against zero trust for users, we enforce least privileges. So give the least access possible for someone to execute their duties when accessing our duties. And remember the attributes that you can use to determine whether a user has to be given access or they have to be denied access. And then transaction. So for every transaction for users, we need to scan all content for malicious and data theft. We have the solutions such as data loss prevention, we have threat intelligence. In our network, we have the advanced analytics, behavioral analytics, user behavioral analytics, and so forth. And then focusing on the applications, zero trust on applications. So for identity, we need to validate the developers that are developing the applications who are accessing our Git repository. We need also to validate our DevOps with strong authentication. So the DevOps process at each and every stage of CI, CD process, we need to validate the actors or the subjects that are doing those processes. We can even implement multi-factor authentication as well, and using of certificates to avoid malicious code being injected into our code repository. And then zero trust for applications against device or workload, or we verify our workload integrity. We can use algorithms such as SHA to determine whether our repository or our code has been tampered with or has not been tampered with. And then on access against zero trust application, the same. To access for users, we need a least privilege. For each application that is trying to access a resource, we need to check whether the privileges that they need, the minimum privilege that they need to do the processes, and we need to make sure that we authenticate the application for access either using certificates or tokens. And then on transaction applications, zero trust for application transaction, we scan content within the infrastructure for malicious and identity theft. So still, data loss prevention against applications. We also need to do content analysis, scanning the activities of an application in our environment. And then the zero trust for infrastructure, we validate all users with access to the infrastructure. So we are saying user X needs to access the server. Are they allowed to access that server? Does their posture or their state allows them to access the server? The credentials, are they allowed to access the server? We are talking of dynamic policies here. So we do not have employee static access, but we dynamically provision access based on the state of a user. And then the next one is identity. Zero trust for infrastructure against device or workload. We identify all devices including IoT. So all devices needs to be identified that are being given access, who they are, the 5 W's, who, where, when, how. We need to check with the 5 W's. What is connecting to our network? How are they connecting? Who are they? Where are they? Why are they connecting? They're connecting from where? So even if they are IoT devices, we need to be granular and be context aware. And then on access, the same, least privilege, and we need to segment access. We just don't say that we are going to provide user X access to all databases. So if user X must access database for system V, they have to only access this database. They must not access any other database within the infrastructure. And then on transactions, we also need to employ data loss prevention. We need content analytics. We need to check the possibility of data loss within the organization from infrastructure activities. We have another zero trust architecture by Microsoft here. So we have the unprivileged environment, which is this one. This is the unprivileged. And then we have the resources zone. This is the resources zone. And here is the decision point. So we have got a subject or a user, a device, an application that is trying to have access to a resource. And we are using different parameters or checks to determine whether the user, the application, or the subject in general meets the criteria that is needed for them to access this. So we can check based on their location, the device attributes, the user details or the application details, the risk associated with that application or user, and possible exceptions that have been configured. And then we can either allow or we can block. So based on the policies that we say that they need to be dynamic, you can either allow or block. So if you allow, then there is access. If you block, then there is no access to the corporate resources. So there's always sharing of information, and we have this continuous validation whilst access is granted. So continuous validation means that we have got this session that we have permitted, and if this session is persistent, we need to continuously validate whether the access that we have given is still standing. If there are conditions that have been violated here, we terminate this connection, and then we know that we are employing a zero trust approach to our environment. Lastly, let's take a dive on the benefits and challenges of zero trust. So in general, zero trust reduces this attack surface and risk, micro-segmentation, not trusting anyone. So there's always reduction in risk when you implement or employ zero trust. And it also provides granular control. So you have got contextual awareness, you have got micro-segmentation, so you have control over access, you have control over activities that happen, you have visibility to your environments, and you can see from on-prem to cloud environments. So you have got visibility through and through in your environment. And it also mitigates the impacts and severity of successful attacks. Remember micro-segmentation, remember contextual awareness, remember analytics and continuous checking. You can quickly see that an attack is happening or is about to happen, and you can quickly stop it, thereby reducing the impact and saving costs. And then compliance. Usually, most organizations in the health, insurance, financial sector, they have to comply to certain uh, standards, GDPR, PCI, DSS, etc., etc. The Data Protection Act. So, with the Zero Trust, it saves you a lot of work. If you implement it, it will cover most of the requirements for you to comply with the authorities. And this centralization of tools, or a centralized tool that allow you to have visibility, allow you to monitor user behavior, allows you to see what has been happening, allows you to play back and see the history. This allows you to have control over your network, allows you to have visibility into your network, and you can make decisions. Remember, we're talking about a network that is self-aware, the network that makes decisions quickly, better than human beings. We are talking about the use of artificial intelligence, the use of machine learning here. We have got advanced zero trust based analytics that you can employ in your network to identify possible, predictive, prescriptive, etc. We have got a lots of opportunities in the contemporary technologies that can be employed through zero trust. Then we are looking at the challenges. So the issue of disruption. Usually you can be disrupted depending on the changes that you are implementing in your network. At times, zero trust may not be matching the current architecture, and you need to do a complete change from the existing architecture to the architecture that you want to achieve. So there's possibility of disruption, and at times it can be lengthy. And then there's also need for you to avoid leaving security gaps when implementing the zero trust security model, because if you don't do your homework, if you don't do your assessment, if you don't do your proper analysis of all the subjects, of all the resources, of all the business processes, there's a possibility of leaving security gaps, which can then be exploited by vulnerability, by threats. These are vulnerabilities that can be exploited by threats. So, and then there are some legacy applications that may fail to be compatible with the zero trust, and this can result in costly updates. You might need to change, rebuild, refactor the applications. You might need to replace the applications to match the zero trust approach. Let's say you want multi-factor authentication and your application doesn't support MFA. You either need to redo the applications or to change the application altogether for it to fit what you want to achieve. Then at times these solutions might be costly. Remember, we've got the policy engine, it might come separate. The policy administrator might come separate. Policy enforcement policy point, it might come separate. We have got the logs, we have got licenses that we need for you to be able to have visibility in your network. You might need to change the whole network altogether for you to be able to have visibility and to collect telemetry and data across your network. So it's a long-term advantage, but at times the upfront cost might be too high, though there is a belief that with time the benefits will offset this initial investment. Thank you for viewing. I hope this has been informative. Follow me on YouTube, LinkedIn, Facebook, Instagram, and Twitch TV for more. For now, bye bye.